All right, greetings everybody. I want to talk to you about how we can use our knowledge of getting recursive to an explicit formula to help us solve one of these tough CBA problems, okay? First, let's go over the sum. We're going to talk arithmetic. We have a common difference, and that's also, you know, when we have a common difference, that's a constant difference or constant rate of change. It's a linear equation. That difference is our slope. Every term we go up a certain amount, and it's constant. Our sum for arithmetic is this formula, n over 2 times the first plus the nth term. Okay? If we don't know the nth term, we have to solve for that. So there's another way of writing this equation here, and I've covered it before. We just haven't really used it. But basically, what is that nth term? It's the first plus n minus 1 times d. And this can kind of be combined, right? Get two of these a sub 1's plus n minus 1 times d. And that helps us, like in this problem we're going to do from the CBA, we were given our sum, and we need to solve for n. And it's going to be a quadratic equation. But we can also show you a way to cheat. Okay? All right. Here was our problem. We were given the 7th term of an arithmetic equation, was 20, and the 15th term is 44. Okay? Our total, our sum of the first n terms is 1855, and we need to solve for what n is. Okay? All right, so basically we need to get the common difference, and then we can start making some equations. The first thing, common difference. Some of this is common sense. I went from 7 to 15, that's 8 terms. In 8 terms, I went from 20 to 44. Okay? So that's basically what is my, I went up from 20 to 44, that's plus 24 over 8 terms, gives me 24 divided by 8 is 3. But I want you guys to realize, you know, we've learned that, you know, the 7th term, 7 on the a sub 7 is 20. So 7 is my input and 20 is my output. Right? We had that table. Okay? First term, you plug in 1. We want to get that explicit formula. Okay? But basically, this value is my output. Here's 7 is my input. Okay? And here's my output, 44, and 15 is my input. So it's basically x, y, x, y. So common sense, we should be able to figure out, hey, we went 24 in 8 terms, and that's 3. But it's also, you know, remember, your common difference is a slope of a linear equation. Okay? Notice how I can use the slope formula. Output minus output equals input minus input. y2 minus y sub 1 over x2 minus x sub 1. Well, here's my y sub 2, that's a15 minus a7, 44 minus 20, and 15 minus 7. Here's your input, right? 15 is what you plug in for n. 15 minus 7. So basically, it's kind of common sense, but I want to show you how it relates to slope. 24 over 8, there's my 3 common difference. It's also the slope of a linear equation. All right, we want to get now the explicit formula. Okay, and remember how we had that table, okay? And where the first term gave me, you know, a sub 1, second term gave me a sub 2, and so on. All right, so what do we know? I can set up y equals mx plus b, and we know my common difference is 3, that's the slope. Well, I've got 2 known ordered pairs, that's all you need is 1. I plug in 15, I get a sub 15, which is 44, or I plug in 7, I get a sub 7, which is 20. So here, notice I plug in 7, 3 times 7 is 21. How do I get from 21 to 20? Well, minus 1, okay? I subtract 21 from both sides. If I subtract 21 from both sides, I get b equals negative 1, but this is pretty easy math here. 21 minus 1 is 20, so there's my b. So here's my formula. Y equals 3x minus 1, or a sub n equals 3n minus 1. So there's my explicit formula. Where first plug in 1, get my first term. Plug in 2, get my second. Prior terms are not required. All right, so remember that. Here's how we can cheat on this problem. notice we've had problems like this where I've got k, I said k equals 1, and I'm going to sum it up, and I don't know what n is, but here's my formula that I've worked out, 3n minus 1. Okay, here's the problem. Okay, I can't put this in, let's see, when I put it in, let's say, a tab mode, like up here, I can't put that in there and create a table without having, because I need two variables, okay? It won't recognize me putting in fact, this should be, sorry, if this is, let's say I use k. K equals 1, here's my equation, or better yet, let's make this, yeah, k equals 1, and let's make this k, okay? And notice this equation, we're going to go up to the nth term. Let me save that. Okay. Your calculator, we can't set up a tab. If I go try to make an equation and create a tab where I can just scroll down and find out when I finally hit a sum of 1855, but this is my sigma notation, which is summation notation. And this tells me, this is my equation of my arithmetic equation in the explicit form. I plug in different values, 1, 2, 3, all the way up to n, when I should get this amount. Okay? Like I said, it will not allow me to put in two variables. Okay? I can't use this summation notation in the y equals x format. So I can't really, but what I can do is trial and error. I can start, I can set this up in the calculate mode and plug in 10, maybe 15, till I get the answer on a multiple choice question. If they want to find out the sum, okay, 1855. So I can plug in 20, 21, 22 until I get this, okay? So that's not a bad way to do it, all right? Because you're going to have a multiple choice, all right? And you can plug in A, B, C, or D and plug in whatever value for n gets me that. Doing the summation of this right here, how many terms does it take to get the sum of that? Remember, this will start off at 1, get a term 2, plug in 3, plug in 4, get all those terms and sum up. How many terms does it take to get that, okay? And you can trial and error that value for n. But we can't graph it and create a table. All right, here's the real way to do it, okay? All right, the real way starts off with that formula that we talked about in the beginning of the slides. To do that, I need my first term. So remember, I've created this, right? Well, I plug in 1. 3 times 1 is 3, minus 1 is 2. There's my first term, 2. Very important, right? Okay? All right, here's that formula, which is basically n over 2 times the first plus the nth term. But we don't know the nth term, okay? But we had to change it so we can just solve for n, okay? There's that 2 times a plus n minus 1 times d. That's the same thing for the sum. We know that's 1855. And we know our first term. Okay, so what I'm doing here is just simplifying here, okay? So notice I plug in 2 for my first term. 2 times 2 is 4. 3 times n is 3n, and 3 times negative 1 is negative 3. Okay? And notice how this 2, what I ended up doing was, I'm going to multiply both sides by 2. So this equation I multiplied, I don't need to do it to both, just one time, because this is multiplication. Okay? And I multiply this by 2. Okay? Notice here's that 2 times 1855. Okay? Notice how that 2 times this gets rid of that 2. So I've got 2 times 1855 is 3710. And here I've got 4 minus 3 is 1 and 3n. So n times 3n is 3n squared, and n times 1 is n, and I've got 3710. So I've got a quadratic equation, but we always like what? Solving for n, we need to get our quadratic equation equal to 0. And that's what our solutions are. Remember, that's what we want to set. If I set this equation equal to 0, values for n that make that true are my solution, right? Solutions are values that make your equation true. All right, so we can keep it like this, but if we're going to move 3710 We're going to subtract it from both sides, so it ends up minus over here. Okay? And there's our equation. Okay? All right, so all we have to do now is 3n squared plus n minus 3710. Notice what I've got here. I graphed y equals 0. That's the x-axis. I've graphed this parabola. It's pretty big. I'm going from negative 50 to 50. That's a negative 100 to positive 100, but I still have, I can get my x-intercept here. I don't want a negative. Remember, we don't, what's our domain for all these arithmetic and geometric equations? Positive integers, 1, 2, 3, 4, 5, and so on. So it's going to be this intersection here, which is 10, 20, 30, looks right about 35, and we get that intersection. Okay, so that's really all I have, but that was a more difficult problem. We'll have one tomorrow that's a little different. Same problem, different numbers. Okay, and we should be able to work through the rest of it, okay? But I want to make sure that's a tougher problem to solve, and I want to make sure you saw that. Okay, then we're going to move on. All right, thank you very much.